Hi, this is Dallas Moller. I'm a senior application engineer with Tektronix, and we're going to go over how to properly set up your signals for high-speed serial data acquisition. This applies to other signaling types as well, but we'll focus on the high-speed serial. So what you need to do, there's a couple different ways you can de-skew this. I have put a splitter in line, so I'm looking at the same signal coming down both of my cable sets, because one of the things we're going to need to do is we need to optimize the acquisition both horizontally and vertically, and then we need to de-skew. So for vertical optimization, you want to make sure that you're using, on the main screen here, you want to make sure you're using close to 90%. We're at 40 millivolts per division on each of these. If we go to 30, we can see that we're clipped because we're outside of it. So we can back off. If we want to get detailed, we could go into the settings and we could set this at 35 millivolts or something and squeeze it. But if you're using 80 or 90% of the screen, you're going to have good vertical accuracies for doing these high quality jitter measurements and signal fidelity measurements. The other thing you want to make sure is that you're sampling at a high sample rate. So I've got the scope set at 100 gigasamples. In the horizontal menu, you have choices. The scope defaults to automatic. I prefer to run the scope in a constant sample rate. That way you're in control, and you can also go to manual to get more details if you want there as well. I typically pick constant. That means this 100 gigasamples is going to stay here. While I'm using two channels, I get the highest sampling fidelity that we've got. I'm going to go grab a couple million points because I want to do some statistical analysis on this. The other thing you'll see is that I'm zoomed in. So the main acquisition is given by these details here. And then we're going to zoom in on a portion of this, and if I click on that little zoom indicator or push the zoom button on the front of the scope, it refocuses these knobs. So I'm zoomed in to look at this waveform, and we're going to look at the skew, because now we're satisfied that we're doing decent. We've got 80% of the screen full vertically. We've got a good high sample rate, and we've captured a long record length. So now we need to check the skew. A couple different ways you can check the skew. Again, as I stated earlier, I've got my signal going through a splitter so that I've got the same phase of signal coming down both cables, because I want to de-skew all the way to the ends of my cables. And if that's the case, we have a tool that helps with that to be very accurate with it. So I'm going to go Analyze Jitter and Eye Analysis, referred to us by as DPOJET. If you go in there and select this, under the timing measurements you can turn on skew. So I'm going to do a skew measurement between channel 1 and channel 3. Those are the two channels that are active. In the configuration, there's a couple things you can check. If you did use a splitter so you have the same phase of signal, then you want to check it relative to the same edge. You could also do this just hooked up live to the device. If you assume that your device is perfect and there is no skew between the plus and the minus, and you're willing to make that assumption, you can do this without using a splitter. You'll have a plus and a minus signal here, and you'll simply change this to opposite as, so it looks rising edge to falling edge if this wasn't the same signal. So we're going to take this capture, and I'm going to hit recalculate. It's going to process that data and tell us that we have minus 4.7 picoseconds of skew is the mean value. You can see there's a spread, and that's based on edge shapes. So what we want to do is take that 4.7, so that's close to 5. So what we're going to do is in the vertical menu of the scope, there's a de-skew. So we're going to say, let's de-skew channel 3, and let's go ahead and move it by that -5 picoseconds. So now we've done that. Now we need to reacquire to see this, but what we can do is I can use the shortcut here, drops me back to DPOJET. So if I hit clear and then single, it rearms the scope for a new trigger, goes and grabs that data and processes it, and we can see we did 16,000 edges and we've got 500 femto. So we're within a picosecond of skew on the cables, so effectively we've de-skewed this signal. Thank you for your time, and remember this feature set is available on all Windows oscilloscopes from Tektronix. It will be option DPOJET.